I was talking about the time range. So instead of 1990 to 2019, that should be 1990 to 2013 because our FO data set is up to 2013 only. So when I did that, data set become balanced. And now you can see when I type xt describe, it's showing us that our data set is balanced data set. So, so you can read something like this: n is 128. That means that one is the number of country. Time period is 24, starting with the 1990 to 2013. You can see the distribution of T. So distribution of T remain constants across all percentile. It is because each cross-sectional unit contains a same time period, and that you can also see through the graph. So that this means our data set is balanced panel data set. If our data set is not balanced panel data set, then you will get a uh, different kind of pattern graph as you were getting earlier. So, so now our data set is balanced. So you work with the data set. Now our data set is in required format. Which one is the longitudinal format? So what I am going to do, I am going to drop unnecessary variable. Which one is here? You can may say ID, duplicate, country name. I'm going to keep, and GDP is here. So there are duplication of country name. So let's delete that one. ISO 31 is the country code provided by the World Bank, and FAO country code, which one is the numeric country code named as country code. That's okay. So first part we do, first we identify and we let this data know our data set is panel data set. So we acknowledge this data about the cross sectional ID and year variable. So we type xt set cross sectional variable one is country code. I think we did earlier also. That's why xt command is working. Otherwise, that can't work. So here now it is showing strongly balanced. Mm, variable of interest in our case one is GDP. So the regression model with which you are going to work today, that one looks like something. So YIT, we may say, I'm writing a linear regression equation. So let's suppose that beta 1 plus beta hat 2 x2 IT plus UIT. So right now I'm not considering unobserved cross-sectional heterogeneity into a regression model. So this one is our simple linear regression model where you are having only one independent one and one dependent variable. YIT in our modeling one is total serial consumption. So this one is the total serial consumption. I will define what this total means. So total serial consumption, and X is here. So X2 in our case to be income. So Since direct income variable is not available uh, with us, so what we have taken, we have taken a proxy of income. And since you are working with the cross country data set, so we have taken per capita GDP. So per capita GDP measured in purchasing power parity, okay, at current uh, international dollar prices, and base year is, this one is that current international dollar, you can say dollar prices. Base year, I think that one is 2000. Uh, I missed to note base year. Probably that would be 2013 only. So, so that is the case. So total cereal consumption we define summing of cereal consumption, direct cereal consumption plus indirect cereal consumption. So direct cereal consumption we know that we consume directly in terms of rice, wheat, maize, okay, or in some other form. Indirect cereal consumptions that we consume via meat consumption. So, uh, so I mean to say, okay, meat we get from chicken, from goat, from pork, from beef, okay, and and say produce a 1 kg of meat. Okay, so let's suppose that probably chicken, in chicken meat case, half kg of cereal required to produce 1 kg of meat. In goat case, that would be probably 3 to 4 kg. In buffalo or bovine case, bovine one is the buffalo meat, bovine, and so in that case, probably 6 to 8 kg of cereals required to produce 1 kg of meat. In pig case again, a little bit more cereal required. That might be a 4 to 6 kg of cereal. Okay, so different quantities of cereal required to produce 1 kg of meat from the different animal. Okay, so what we do, we standardize this one, and we consider on average 3 kg of cereals required to produce 1 kg of meat. And in our data set, you are having a meat variable, and this one is the total meat consumption. At FAO, we can get meat consumptions from different animal data set also. So since I took a total meat consumption, so first I need to convert the meat into indirect cereal. So let's generate that variable. So I'm generating feed equal to meat. Since meat is here again measure in per person per annum consumption terms in kg. So I'm generating meat multiplied by 3 This gives us feed variable, which one is indirect. Okay. Hello, am I audible now?
Yes, sir.
So, feed become a indirect serial consumption, and now I'm going to generate total serial consumption, which one is our dependent variable. So for this, I'm usingegen command,egen total serial, so total work, and I'm adding serial and meat. So now I have total serial consumption, and this one is the serial per capita serial total serial consumption per person per annum measured in kg, and GDP one is per capita GDP measured in purchasing power parity at constant international dollar prices. So that means both our dependent variable and independent variable are in real terms. So now the variable is ready to run a regression. But before running a regression, let's plot these two variables so that you will have an idea what kind of relationship these two variables are having with each other. So for that, we plot, and for plotting, command is
Excuse me, sir.
yes,
Yeah, so what's the difference between using gen command oregen command?
uh,
Like, why can't we use
gen,
gen t serial equal to row
uh,
total serial?
gen one is usual command that give us a new variable depending upon what kind of arithmetical uh, method we are going to use. Agn one is the extension of gen command. So this give you a more you can say freedom to generate your variable. So you can manipulate your arithmetical equation with the agent command. So
Okay, sir.
just type on this data agent, you will get a usage of agent command. But that's
Okay.
in most of the time, of course, we use both agent and uh, gene command according to their use. Like here, I generated total serial consumption. So I may use this one, generate total serial. Let me generate one more, serial one equal to serial plus feed. In earlier I made a mistake. I added serial and meat. That should be serial and feed. So this one, so drop total serial first there, and again use engine. Here should be, it should be feed. And now compare both of these two. Both of these two command gives us same value of total serial consumption. Can you see that?
Yes, sir. Yes, sir.
So, uh, so the limitation of using gen command here. So here you are doing a simple arithmetical things. So uh, both gen and total serial work. But let's suppose that we require to add a particular variable for each cross-sectional unit. Okay. So again for that, if you go by using by ID, then your write gene command that give you that output, but more easy to useegen command. So if you useegen command, so here I have written row total. Row total here means you are making a you are doing a totaling using, and we are doing totaling row by row. Let's open again. So browse this one and add here serial and feed. So for each row, we are getting one output variable. So that means you are here totaling row by row. Let's suppose that if you require to make a total something like this, if you want to add this much of observations, because this, let's suppose that this one is belonging to a particular cross section area. For that, we need to type just is in total serial equal to total serial feed by country ID. So that give you a total serial consumption by country ID. So that become a column total. And there is many more uses of total. Suppose if you want to create a median by cross-sectional ID, or you want to go with the constant value or minimum value or maximum value. So there are many uses. So as I told you, gen1 is the extension of gen command. So just have a look on this data manual. From there, you will get a more clarity on it. So I have used row total command for generating total serial consumption. Now plot these two command, sorry, these two variable. So total serial consumption one is dependent variable and GDP one is independent variable. So for that, we type graph two-way, make a scatter graph, total serial, and then GDP. So it's showing that scatter is not a two-way because I made a mistake. So this one is scatter, SCATTER. Okay, total serial, CARAL. So look, it's look like this. So it is starting somewhere around 10 or 20 unit of serial consumption, and so, so along with the rise in income, it rises steeply. Then after curve started flatten, and these are the country which we may consider. Uh, these are the country which one having a very high per capita income, but consuming on average 3 to 450 kilogram total cereal consumption per person per annum. Looks this one I am talking about. I am moving cursor there. So these are the country which one having a average income, at least according to this graph, income between 20,000 to 14,000. This one I am talking about. Income around 40,000, but consuming around 500 kg total cereals per person per annum. And look this country. So this particular country, particularly this group of country having a substantial low level of per capita income, but consuming very high level of total cereal consumption. So if you can see this graph, So this graph shows us that there is a non-linear relationship between total cereal consumption and income. And if we remove this country, let's suppose that I'm going to remove this high uh, income countries, which one having a more than 40,000 uh, per capita per person income. So with that, this graph expanded and it's clearly like you can see there is a non-linear relationship between these two variables. So up to 30,000 range of income, let's suppose that if I'm going to consider this one, so we can found a monotonic relationship between total cereal consumption and income. So that means with the rise in income, there is rise in total cereal consumption. So this one is the one graph. Another graph I am going to show you where I am just plotting cereal consumption instead of total cereal consumption. If I plot this one, it looks like this. So those countries which are having a substantially low level of income, consuming very high quantity of cereals as a direct food consumption, or you can say consuming high amount of direct cereals, and as the income rises, there is a decline in cereal consumption. Though we can't exactly, uh, and for a richer country, particularly those who are having a 20 or more thousand of per capita per person income, for them, we find there is no relationship between cereal consumption and income. Okay. That is looking on this panel data set. Okay. It might cross-sectional data set give us a different impression, or in that case, we exactly get a negative relationship between cereal consumption and income. Since this one is the panel data set, so the graph looks like this. Just look have another graph which one is the meat consumption. The meat consumption. It look like this. Here we are getting a positive relationship between meat consumption and income. So with the rise in income, there is rise in meat consumption, and at every level, of course, the relationship is not monotonic, particularly with this country. But if you remove this country, so this country I am talking about, if you remove this country, then you will get a almost a monotonic relationship between meat consumption and total cereal consumption. Sorry, meat consumption and income. So I'm showing this one to you because this one is part of my PhD work. So I work on it during my PhD, and 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 this one is also an important part of development economics. Particularly when we read articles on poverty, where if we can say found a discussion of way of measuring poverty. So we know that mainly there are two ways of measuring poverty. I'm talking about the measuring absolute poverty. So broadly we categorize poverty into two parts, absolute and relative poverty. Then after there are several methods of measuring absolute poverty, relative poverty. So the two and the widely used method for measuring poverty, one is income, you can say criteria method and calorie consumption method. That also called a basic needs approach method and second one is I think biological approach method. So famously we know income method and calorie consumption method. So for a calorie consumption we require to define a benchmark level of calorie. India used to measure poverty using calorie consumption till 2009 and 10. With the Tendulkar committee report, Tendulkar discarded using calorie consumption method for measuring poverty. But again, Regression moved back onto calculating poverty using calorie consumption method. Though Regression report has not been accepted by Government of India yet, so the official method of measuring poverty one is the Tendulkar committee methodology only. So when we read more on this poverty and poverty debate, we encounter with the concept of this total cereal consumption and cereal consumption. So this particular concept proposed by Professor Usha Patnaik, who was earlier professor in Jawaharlal Nehru University. So, so in a poverty debate, we come with a argument that where uh, Patnaik argued that the total cereal consumptions can be taken as a proxy for income, proxy for real income. So we may wonder why I have included a income here. So there is again debate on it. So professors like Usha Patnaik since long time have been argued that there is a decline in real per capita income for a substantial majority of population, and that decline particularly happened in a post-liberal economic reform era. But in counter of that, there are many neoliberal economists who argued that, who argued contrarily, and they said that liberalization benefited all, though not equally. But in a liberalization era, there is a substantial rise in per capita income, real income, per capita real income I'm talking about. So the question arises why there are two different arguments, comes from two different group of academic. You can have two different group of academia. So the answer of that lies in a way we construct or we calculate real income. So we know for calculating a real income, we divide nominal income with the price indices, and for price indices you use either Pasky price indices method or Lespius price index method. So in India, for calculating a price indices, we use Lespius price index method. And in a Lespius price index, we know we keep weight as a weight fixed and consider variation in price over a period of time. So a problem of that particular method is that because we keep weight as remain constant over a period of time, that gives a underestimation of rise in prices, and because of that underestimations of price indices, we may say we get a higher value of real income.
Excuse me, sir.
So yes,
Sir, I have a question, sir. In India, don't we measure poverty using the headcount ratio?
and condition is a quantitative approach.
Okay,
For
sir.
identifying a poor, okay, first we need to theoretically define who is poor, and for that we use calorie consumption method.
Okay, sir.
So I think when you will be in your fourth year, I think Arindam Banerjee offer a course, and in that Banerjee discussed a little bit on direct cereal and cereal consumption.
Okay, sir.
Has he taught any course to you in or teaching any course to you in this semester? No, in this
No,
semester
sir.
he is not teaching any course. What about the
No, sir.
first
He's
year?
not.
In first year,
Sir, he taught us two courses.
he ever taught you?
First semester he taught us TVD, and second semester he taught us CCD.
Okay. In both of the courses, there is no discussion on that direct, indirect feed consumption.
Sir,
Because I do not know in which course he discusses all these things. Yes, yes, sir.
no, sir. Sir, I don't think. Sir, he mentioned something about how in certain countries, certain commodities which are cereal plays a vital part in the political economy, but not in detail, like not cereals in particular.
Okay. As he mentions about the Euthyphilus curve, but he has expectation on it. He has this expectation because he was a student of Professor Utsa Patnaik, and his area of research is agrarian sectors, and this much related with the food security also. Okay, anyway, so so that one is the drawback of less fierce price index, and because of that inherent drawbacks in calculation of less fierce price index, we get um, underestimation of price indices, and that get reflected in rising real per capita income. So Usha Patnaik argued that let's discard that method where you use price indices in a denominator for calculating a real per capita income. Instead of using that, let's use a calorie consumption or cereal consumption. And in an India case, Usha Patnaik shown a figure in which uh, she shown that since total cereal consumption is declining in India, despite in rise in per capita and a conventional rise in per capita income. So uh, there is a rise in poverty, or we can say instead of rise in per capita income, actually there is a decline in real per capita income over a period of time. And for that, uh, since she has chosen a total cereal consumption as a proxy of per capita income, and sorry, for arguing that she has chosen the total cereal consumption as a proxy for per capita real income. In contrast of that, the other economists, particularly Angus Deaton, argued that we can't take cereal consumption as a proxy for real income because of several reasons. I'm not going to mention that those reasons because that's entirely diverted our topic onto a different things. Okay, but you found those reasons and discussion between Usta and Angus Deaton in a EPW article. So in year 2009 and 10, there were a series of articles written by both Usta Patnaik and Angus Deaton in which they argued against one another, and substantial part of Angus detained argument one is since we can't see anything relating with poverty which based on this particular assumption. And since Usha Patnaik proved this and left this argument unproven, so no further discussions, particularly published in APW since then till 2013. I tried to investigate these particular assumptions in my PhD, and for that I used this variable. And since I shown you when we see the relationship between total cereal consumptions and per capita real income, what we are getting, you are getting a non-linear relationship between these two variables. So of course, uh, we need to do a non-linear regression model for capturing the causal uh, relationship between these two variables. So I did that. I used two non-linear regression models. The one is called a Gumpard and the another one is called logistic model, and estimated the parameters, estimated the you can say the goodness of it. And apart from doing the these two non-linear regression model, I did or I estimated two linear regression model also. The one is called a log-log model, and the another is one is quadratic regression model. So, and for that I transform these two variables, total cereal consumption and GDP, into log form. So let me transform that. So generate total cereal. Let me type ln total cereal equal to log of total cereal, and then generate log of GDP equal to log of. Now we are having both of these two variables in log, and if I put these two variables, so now I am plotting transform variable log of total cereal again the log of GDP, and if I do that, what I so excluding this country, if each outlier, okay, and go with the remaining country,
Sir,
what we get?
excuse me, sir.
We
Sir,
get
your
a
voice is
exact
breaking up.
yes.
Sir, your voice is breaking.
Okay, let me check. Probably because of internet connection. Clear now? Is it clear now?
Yes, sir. Yes, sir.
No? So, so after transforming both total cereal consumption into log and GDP into log, when I plot it, okay, we are getting a linear relationship between these two variables. If I exclude these outlier value, so in that case we exactly get linear relationship between these two variables. So what you are going to do, since you are working in the basic panel data regression model and you are considering only linear balanced panel data set, so you are going to work with the log of cereal consumption and log of GDP variable. So the first task with us will calculate a summary of all the variables. So since you are working with the two variable only, so let's calculate summary of log cereal and log GDP. So this one, the XT summary. That give a simple summary statistic as usually get in a cross-sectional data set. But when we type this XT summary with the XT summary command, we are getting a mean, standard deviation, minimum, maximum value. So mean you are getting for a overall value, which one is the same as like the above summary command. Apart from that, we are getting a between and within standard deviation and minimum and maximum value observations. Total observations in terms of capital N are given there. N1 is the cross-sectional unit, small n, and T1 is the time period. So with the XT summary command, we are getting standard deviations across cross-sectional unit and within cross-sectional unit. So, so the between one is the across cross-sectional unit. So between I told you last time when we were working with the theory, when we will take a average of a particular variable for each cross-sectional unit, and after taking an average, when we compare that average with the other cross-sectional unit, that give us between variation. So when you take an average for each cross-sectional unit for a given time period, so here you are working with the 24 year of data, I in our case 28. So what we will take for each cross-sectional unit, we will take a average of GDP and total serial consumption. So in case of GDP, suppose that GDP become sum of GDP divided by 24 for each I. So this one is the GDP I. So in that case, we will get 128 cross-sectional value. And when we calculate the variance and standard deviations, so that one is here. So this one is the between variation. And within variation, given in terms of standard deviation, one is this one. So in the case of total serial consumption, remember I haven't removed outlier. So for getting a robust estimates, we required to remove outlier first. So without removing an outlier, the between variation one is the 0.37 and within variation one is 0.08. Within variation, we are comparing a variation for each cross-sectional unit over a period of time. So that one is the 0.08. That means so over time there is a less variation in total serial consumption as compared to cross-sectional variation. In cross-sectional case, variation case, you are getting a higher standard deviation. The similarly we will get in case of GDP. So in GDP case again between variation is much higher as compared to the within variation. So this also indicate us that there is a substantial cross-sectional heterogeneity across cross-sectional unit. So this one is the XT summary command. After that, we use regress command for estimating full regression model. I am using ln total serial and ln GDP. If I go without mentioning any robust and using any robust standard error and run a simple linear regression, implicitly assuming that all cross-sectional all observations are independent from each other. So in this case, we are getting R square equal to 0.57. That means 57% variation in total serial consumption explained by income only. So that means more than half of the variation explained by a single explanatory variable, which one is income. And if you see the coefficient, check the significance of coefficient. So both constant and coefficient value of log GDP are statistically significant. And, and if you interpret the regression model, then we can say if there is a rise in 1% income on average, total cereal consumptions rise by 0.24%. And standard error note down, standard error is substantially low here. In a case of log GDP, standard error is 0.003 only. But as we discussed in the theory, even in a case of presence of unobserved cross-sectional heterogeneity, we get a correlations between error terms. And because of that correlations, if you go with this fold regression model, even assuming that there is a no endogeneity problem, so assuming no endogeneity, you will get a autocorrelation heteroscedasticity problem here. So of course the fold regression model without incorporating any kind of robust standard error doesn't and give us efficient estimate. So what we do, we use cluster robust error to cluster. Cross sectional one is country ID one is the cross sectional unit. So I use that. Where that has gone. So country code and enter. Now we compare both of these two regression. So in an earlier case, we are getting a substantially low level of standard error. That because of autocorrelation problem or because of cross-sectional, error terms are related with one another within cross-sectional unit. And after incorporating the cluster robust standard error, we get a higher standard error. So earlier in case of log GDP, it was 0.003 and now it is 0.0194. Coefficient remains same in both of the cases. Any doubt? Any doubt here? Can you hear me?
Sir.
Hello?
Hello, sir.
So any doubt?
Sir, am I audible?
Hello? Yeah, I can hear you.
Sir, I just want to ask that don't we always prefer a lower standard error because it will affect the significance of the variable?
Preferring lower standard error if if it comes without any other kind of problem, then in that case it is good. But if there is a problem of heteroscedasticity, autocorrelation kind of things, okay. So in that case, you do not get an efficient estimate of your parameter. And since you do not get an efficient estimates, okay, or precise estimates, you can say instead of uh, uh, saying efficient estimates, you do not get a precise estimates, and if you do not get a precise estimates of your parameter, in that case, for your T and F statistics, result would not be, and it would, T and F statistics do not give us reliable result. So So because of that reason, we always try to get a precise estimates of variance of parameters. And to get that, you use reverse standard error. Like in a autocorrelation case, you always get a underestimation of true standard error. And when you use this particular, and when you use the reverse variance, we get higher standard error as compared to when regression models suffer with the autocorrelation problem. But what about the heteroscedasticity? In a heteroscedasticity, we may get a higher standard error, but after removing heteroscedasticity, standard error goes down.
Okay, sir.
So that is the case. So we always try to get a precise estimate of the parameter.
Thank you.
So, sir, if there is no problem regarding heteroscedasticity, we can have a high standard error.
Of course, yes. Our objective is to get a precise standard error. And blue estimation in a blue will get only when all assumptions of classical linear regression model satisfy. So in that case, we check heteroscedasticity, model specification, autocorrelation, and other kind of problem. So only when we ensure that a regression model does not suffer with any kind of problem, then we can go with the calculated standard error, and which we consider the correct standard error.
Okay, sir.
So that's it. And that's because if you are getting a higher standard error, T statistics goes down from 64.72 to 12.42. And since no one, and particularly when you talked about the heteroscedasticity and autocorrelation test, so these are not the absolute test. So heteroscedasticity does not measure only heteroscedasticity problem. It might be that there is no heteroscedasticity, but because of some other problem, regression model showing, and it is regression model showing us heteroscedasticity problem. Are you getting me?
Yes, sir.
Similarly, in a case of autocorrelation, so here if we might getting autocorrelation problem because of unobserved cross-sectional heterogeneity. If you remove or get rid of unobserved cross-sectional heterogeneity, might be there is no autocorrelation problem. So just because going with the one test doesn't mean that that one is a absolute test for that particular kind of problem. Or that could be, and that one is a different test for particular kind of problem. So this one is for full regression model. Second, after running a full regression model, we are going to run a fixed effect least square dummy variable regression model. And for running a fixed effect least square dummy variable model, we require to use cross-sectional dummy in our regression model. And cross-section is country ID. So I am putting country ID there. Country code. And if I enter, what you get coefficient value of log GDP, and then coefficients of dummy variable, and then constant term. And we can see not only log of coefficient value of log of GDP is statistically significant, but also uh, excluding few, almost all countries' damage are statistically significant. And look here the R square. R square now become 0.96. That means 96 of the variation in total cereal consumption explained by all these variables. So accounting cross country heterogeneity into the model, R square become 0.96. We may add a time dummy here. Here also square log of GDP coefficient value 0.11 again statistically significant. Here excluding later period time dummy and the initial period time dummy, the year time dummies are statistically significant.
Sir,
Yes, anybody?
your voice went away, sir. Could you repeat?
I'm repeating.
Hello?
Let hello.
Yes, sir. Please go on.
Okay, let me check. So I ran a two regression model here. The one is including cross-sectional damage and other is including both cross-sectional and time damage. If you can see on this data result, earlier I used only cross-sectional damage, high country code. And in that case, we're getting R square 0.96, coefficient value of log GDP is statistically significant. In value term, it is 0.15, and almost all cross-sectional damage coefficients are statistically significant. When I included time damage, R square increase a bit, coefficient log of GDP coefficient declined by 0.04, 0.04 point, and again we are getting almost all time damage are statistically significant. So this means that accounting cross-sectional and time effect, 96% of variation in Y explained by X only. And this also shows that there is time effect and also fixed effect. Fixed effect because cross-sectional damage are statistically significant. Time effect again for the same reason because all time damage are statistically significant. And look here, this p-value are using two-tail test. When you move on to the one-tail test, then all cross-sectional damage and all time damage become statistically significant. We talked about the drawback of this particular model. We lose a substantial degree of freedom, since here you are having a very large data, and we consider this one is a good data and large sample size, because you are having a 128 country over a 24-year period of time. Okay. So n is substantially larger compared to t, so there is a you can say no risk of losing substantial degree of freedom, so you may go ahead with this particular regression model for estimating coefficient value of log GDP. So if you want to go ahead with this model, then we require to check the heterosidicity, autocorrelation, contemporary autocorrelation, so that you will get a precise estimates of your parameter. In precise when you get an inconsistent and efficient estimates of your parameter. Next approach one is here is fixed effect model or random effect model. Just a minute. So it's already 3:40. So shall I stop here so that you will cover fixed effect and random effect in the next class? By the time you will work on it, okay, make data set, data as a panel data, work with the full regression model and fixed effect regression model, and also come with a little bit reading on fixed effect and random effect. So in the next class we will do that, and we also talked about the associated diagnosis test of fixed and random effect model. So this much for today. Okay. Stopping this presentation, and also